If you are into any field which deals with some large numbers, you might have probably seen numbers like these by now. These numbers are called scientific notation. This is just a simple way to represent this. When we deal with large numbers or very small numbers like these, it's too long to write or to do some math operation on it. Even reading it, it's not that simple. We need some big words like quadrillion and quintillion. So we use this scientific notation for big numbers. Now let's see how these numbers are formed. We will take this number for example. No decimal point is shown here. So we know that the decimal point is right here. We will take the decimal point and move it next to the first digit from left side. We will also count the number of steps needed to reach our target. Write multiplied by 10 and write the numbers of steps as its exponents. Now get rid of all the zeros. Now we have successfully converted a regular number to scientific notation. We can make it even smaller by getting rid of some more numbers from the right hand side, but that will reduce its accuracy. We will take one more example. Now this is a really small number. Here the decimal point is way up here. We have to bring it down next to the first non-zero digit from left. Just as before, we count the number of steps required for the decimal point to reach the target. Only difference is that we have to count it backwards. We will start from -1, -2, -3 and so on. Once target is reached, remove all the zeros on the left side and then write 10 and the number of steps as its exponents. Here are a few examples. Answer will be revealed soon. So pause the video if you want to give it a try. Let's use this example. We can see both numbers have different exponents. So the first thing to do is to make both of them equal. We know that when decimal point is moved to right, the exponent decreases. So we will move this decimal point until both the exponents become equal. Now that they have same exponents, we will add these two numbers and write the result followed by 10 to the power of the same exponent. Now the result we have is not appropriate according to the notation. It has 3 digits on the left side of the decimal point. So we move the decimal points to the left until it has only 1 digit on the left side of the decimal point. This now is the correct answer. Now let's try a subtraction example. As we can see, these exponents are already equal, so no need to equalize them. Just as before, write 10 and its exponent below. Now we will subtract. And this is the result. But this too is not appropriate according to notation. It has a 0 on the left side of the decimal point. So we move the decimal point and change the exponent accordingly. Here are a few examples. Answer will be revealed soon. So pause the video if you want to give it a try. Next, we will have some multiplications done on these. Multiplications are actually very easy. We just add these exponents and multiply these numbers. It is as simple as that. Keep in mind to move the decimal point if the numbers left to decimal point is 0 or more than 9. Divisions. These are just like multiplication. The only difference is we subtract these exponents and divide these numbers. Again, keep in mind to move the decimal point. Here are a few examples. Answer will be revealed soon. So pause the video if you want to give it a try.